Hi guys, welcome to the Spatial Data Visualization and Machine Learning in Python course. In this course, we will be building a spatial data analytics dashboard using Booker and Python. So Booker is a very powerful data visualization library that is used for building a wide range of interactive plots as well as dashboards using the Python programming language. So it converts the Python code into HTML and JavaScript code, which then allows the plots to be hosted on servers and displayed in web browsers. So our dashboard is currently displayed in a web browser and it is hosted on a server, right? So the reason why it's better to host it on a server is because you can share it with multiple people who have access to that server via a URL. So we will also be building a predictive model that we will use to do a further analysis on our data and then plot the forecasted results alongside the data set that we will be focusing on. Okay, so we will be visualizing our data using a variety of plots as you can see before you, right? Um, so all of them are basically Booker charts. So they are all available in the Booker library. So we haven't used anything alongside Booker besides only Booker. Okay, so we will then be exploring each and every one of these plots in depth. And once we understand each plot in depth and how to build each plot, we will then be equipped with the knowledge to build this entire dashboard. Okay, and then we will use the dashboard to be able to analyze our data. Right, so when data is in raw format, it's very difficult to make sense of it. So that's why we build visuals and reports and dashboards in order to make it easier for us to gain insights from the data, right? So once we have built our dashboard, we will then create a lightweight server like I already have that we will use to serve our dashboard and then make it available or accessible via a URL. So we'll be brushing up on a couple of topics like visualizing spatial data using maps, as you can see here, as well as charts. Okay, and then we will also be doing our data analysis and pre-processing, etc., using Jupyter Notebook. And we will also be manipulating, cleaning, and transforming data because it's not that easy to just take the data and visualize it in graphs. It needs to be transformed, it needs to be cleaned. Like, for instance, our spatial data needs to be transformed. We cannot use the latitude and longitude values to plot the data on the map. So there needs to be some pre-processing done on that, which we will cover as well. And we will also learn how to use the Booker library to build charts in depth, right? And then we will also learn a bit of machine learning using geospatial data in order to forecast future data, right? That we can then use to plot in our graphs as well. And then, yeah, we'll just cover basic geo mapping. So this is not entirely a GIS application, but a portion of this course is also um, dedicated to geo mapping as well. But ultimately, we want to create a dashboard. Okay, so basically, Booker comes with a toolbar that we can use to interact with our either our map or our graphs, right? Depending on what you want to do. Let's say, for instance, we want to zoom in our map. So if we scroll with the wheel, nothing happens. So because we need to use the toolbar that Booker provides us with, so we will then select the wheel zoom And that will then allow us to zoom in to our graphs, right, and into our map specifically if we want to um, get a little bit of insight as to what is going on. And then the same toolbar applies to each and every one of these plots depending on how you set it up. Like for instance, this plot, I set it up in such a way that you cannot really zoom in and out of it because it's not necessary, but these you can. Okay, and this one as well, right, as well as our bar chart. If we want to see exactly or zoom into a specific um, place in our charts, we can do that. So these graphs are quite interactive, and I'm sure at a later stage we can, or another course, we can also start building real-time dashboards that get updated in real time so that we can see the data being ingested and the insights being derived in near real time. So we'll see the charts moving. Okay, and we can also, once we have fiddled around, we can then decide to reset. So we have a reset uh, button here as well that we can click, and then it will reset our dashboard and make it look neat again. Okay, so what we basically are doing here is that we are analyzing significant earthquakes as well as predicting um, significant earthquakes for a year in advance. So we are using earthquakes ranging from the year 1965 all the way to 2016, and then we will predict the earthquakes that will occur in 2017. So we'll use the 1965 to 2016 data set as training data, and then we will predict our future earthquakes for the year 2017. We will also be validating our models using real-time data that's derived from an API to see exactly how accurate our predictions are. And as you can see, I have plotted the predictions alongside the training data, so you can see that it's more or less um, in the same areas. So it's definitely not that bad of a prediction, right? And here we also have the maximum and average magnitude by year. So each year we will take the maximum magnitude, so the strength of the earthquake, right? And we will plot it alongside the average magnitude of the earthquake for each year. So each dot represents a year. If you hover over it, you can see it's the year 1966. We have the average magnitude as well as the maximum magnitude for that year. And we can see we have some strong earthquakes towards the year 2004 and 2011. And as you can see, we have predicted the maximum magnitude for the year 2017, right? Which tells us that we have weaker, or yeah, basically a weaker maximum earthquake value for the year 2017, right? So it's not as severe. And the average as well is basically the same, more or less around 5.5, right? The magnitude of 5.5. And in the year 2017, we have predicted a magnitude of about 5.8. So it seems to be in line with our training data. So the training data and the testing data are derived from different sources. So it's good to see that even though they come from different sources, that our predictions are reasonably accurate, right? And yeah, so we also currently have the types of earthquakes for the year 1965 up until 2016. So our training data doesn't only contain standard earthquakes, but also nuclear explosions, as well as explosions and rock bursts. So we can see the majority of our data set contains earthquakes, and that 23,229 is the number of earthquakes in our data set, and 175 of them on nuclear explosions, and the others is very difficult to see because it's so little compared to the earthquakes. Okay, so we can see not all of our data comprises of standard earthquakes, right? We can see that when we look at our donut chart, and then we also have a trend line, kind of like a plot, which is our line chart. So we tried to see if we can identify some sort of a trend starting from 1965 up until 2016, right? So we can see these are the number of earthquakes that occurred in each year, right, according to our data set. And as you can see, it's slightly increasing over the years. So we are getting more earthquakes um, towards the year 2000 than we did in 1965. I don't know if that is a good thing, but we can see in the year 2011, it definitely was a tough one because we have about 712 earthquakes according to our data set. So that tells us that was a pretty rough year. And we can also look at the maximum magnitude for that year, which was about 9, which is really, really severe. But we have predicted that it basically goes down, right? And we can see it here. The number of earthquakes have dropped since 2012, right? And it's kind of like stable at about 400 earthquakes towards 2016. Okay, and when we look at our bar chart, we are also basically visualizing the number of earthquakes for each year, but using a different type of plot, which is our bar chart, right? Which gives us immediate feedback as to, like if I point over this bar, I can see that the year 2011 is the year with the most amount of earthquakes according to our data set. We can see that when we look at the um, line chart as well, and we can see it more evident when we look at the bar chart. So that's why we visualize our data using different types of charts, so we can view it in sort of like a different viewpoint, right? So if we hover over each bar, we'll see the year and the number of earthquakes as well. So it's very easy to pinpoint the year with the least amount of earthquakes, which looks like that one. And that's the year 1966. So there's about 234, right? So basically, we'll be able to do some basic analysis with our dashboard on earthquake data, which otherwise we would not be able to do if we didn't visualize the data that we are working with. Okay, so um, that's it for this video. I'll see you guys in the course. Thank you.